Welcome to another video podcast. In this episode we're going to be taking a look at how to calculate areas between curves. Let's go ahead and start off by sort of identifying the problem here, and then we'll jump into the calculation. Looking at this particular example, we have two curves, y equal x and y equal x cubed. Let me go ahead and label them in the graph that we've provided here. And it says find the area bounded by the curves. Remember, bounded means the curves enclose the area or they surround the area. And so for this particular example, what we want is we want this area here, which I'll call area 1. And we also want this area here because it's also enclosed by both curves, and I'll call that area 2. So it's those two areas that I'm interested in, and from the start of the problem, the other thing that I'm interested in are these intersection points. The intersection points are going to let me know how far to integrate in each case. So if I start off trying to find the intersections, remember you find intersections by setting the two curves equal to each other, then I'm going to set x cubed equal to x. Let's do a little bit of algebra here. I'm going to solve for the intersection points. We'll pull out an x. And now we have it in a nice sort of factored form here where I can recognize the zeros. The first one is x equals 0 from this factor. And this factor is going to give us x is plus or minus 1. Alright, if we keep going with this, so here's the point x equal to 1. Here's x equal to 0. And here's x equal to negative 1. Alright, for each of those 3 points, we're going to generate two different integrals. And the first integral, well, the total area that we're looking for is divided into the first area and the second area. And I'll color code this so we can make sure we understand which one I'm using. For area 1 is equal to, well, remember, the idea is which function's on top and which function's on bottom. For area 1, the function y equal x is on top, and x cubed is on bottom. So area 1 would be the integral of x minus x cubed dx. And the limits of integration here, well, it goes from x equal to 0 up to x equal to 1. So the limits of integration would be from 0 to 1. Similarly, if I look at A2 ranges from minus 1 to 0, and on top is x cubed over that interval, and on the bottom is x. Now that I've broken the region up into two integrals, I can easily evaluate these integrals now, which we'll go ahead and do. And I should be looking for some sort of positive area here. Remember, this is the net area that we're looking for. So evaluating this first one, we get 1/2 minus 1/4. Evaluating the next one, the 0 doesn't contribute, so I'm going to get minus. If I stick the negative 1 into here, I get 1/4. Negative 1 into here, I get minus 1/2. And so just looking at these two, we get positive 1/4 here, minus negative 1/4 here. So there's a total of 1/2 area inside these two curves. Now, the main thing that I want you to be thinking about through all these videos and doing your homework as well is, can I set up the integral? For this material, that's the bigger question. It's not can you do the integration. We've already covered integration this semester, so in some sense I'm assuming you can do that. But it's really, can you set up the integral properly from the beginning? And sometimes it may result in multiple integrals like this problem did. There's going to be several more videos in this series that I want you to check out. Each one's going to get progressively a little more difficult. We're going to add a couple of new wrinkles. But they're all basically the same ideas. locate the areas that are involved, figure out if you're going to integrate vertically or horizontally. If it's polar curves or parametric curves, you have to do some special things, but most of the problems are very similar. All right, thank you for watching.